Okay, we're recording now. Okay, so we're here. I'm starting 2.4, so I'm actually a little bit ahead. That being the case, I won't go that far. Then I'll stop and give you the quiz as usual. And we have a 4-day weekend. No school tomorrow, no school Monday. Our next meeting after today is Tuesday, so just everybody have a nice 4-day weekend. And the quiz is just like before. You should know the rules for the quiz. I'll give you the quiz. I'll project it. Get started. It'll take me a moment to set up the breakout rooms. And then you go to your breakout rooms. Put your first and last name. Everybody else in your group, first and last name. And you try to get the answers right. And you try to get all your teammates to get it right. And I'll look at all of them, but I'll grade only one of them. And so everybody will get the same grade. So the only way to be sure to get full credit is for everybody in your team to get it. And it doesn't matter who I pick. Then you'll all get full credit. And that's been generally the case for the first one. All right. So let's go back and do more 2.4 introduction to epsilon and delta stuff. So reminder of where we were. So this is all stuff I gave yesterday. So Greek letter delta, lowercase delta. Again, there's a triangle delta also. That's uppercase. Lowercase delta, small change in x. Epsilon, funny looking e, small change in y. Here's delta, here's epsilon. Okay. Distance between x and a. Well, if x is bigger, it's x minus a. If a is bigger, it's a minus x. You don't want to worry about which is bigger, which is smaller, the absolute value. So in general, the distance between x and a is absolute value of x minus a. By the same logic, this is in the x direction. In the y direction, distance between f of x and L is absolute value of f of x minus L. Okay. Think of that as being y. Okay. Distance between x and a is smaller than a certain number delta. Absolute value of x minus a is less than delta. Same thing, except it's not allowed to be 0. So when we take the limit, we're not allowing x to equal a. So we insist that it's greater than 0. So 0 less than absolute value of x minus a is less than delta. And the distance between f of x and L is less than epsilon. Absolute value of f of x minus L is less than epsilon. Okay, that's what we had last time. And now show you some stuff in the text. So 2.4, precise definition of a limit. Page 104. Page 106. Precise definition of a limit. If you want to put this whole thing on your cheat sheet, you may. Okay. Limit as x approaches a of f of x equals L. You probably don't have to copy all of this stuff. Right? Just here and all this down. Limit as x approaches a of f of x equals L is for every epsilon greater than 0, there is a delta greater than 0, such that if 0 is less than absolute value of x minus a is less than delta, then absolute value of f of x minus L is less than epsilon. Okay? Very formal definition of the limit. Okay? So we talk about close, and I've been using close to y, close to 2, close to 3, and in mathematics that doesn't sound very precise. Right? So how do I get a more precise definition? Close. Well, how close do you want? So you give me a challenge number, so to speak, an epsilon greater than 0. That is how close I want to be to the limit. Then I can find a delta. I can find a corresponding close value, okay, a delta, so that whenever this is true, so this is a definition of x is close to a, except x is not equal to a, then y, or f of x, is close to L. So this can be thought of as x close to a, y close to L. In fact, I'll write it in my book since I know it. So x is close to a, and this is y equals f of x close to L. So x is close to a, that 0 less than absolute value of x minus a less than delta. That's the meaning of x is close to a. Okay. And then the other side, y for f of x is close to L. Okay. And in this case, we're insisting that x and a cannot be equal. We don't make that claim over here. F of x and L are allowed to be equal here, but not over here. Okay. So this is what you want to get down. In terms of writing it in your cheat sheet, start from here. You don't need any of this top stuff. So that and that and that. Okay. Now here are some pictures. This is actually an exaggerated picture on page 107. Okay, we claim the limit as x approaches a of f of x is equal to L. Seems reasonable. So how close is close? So the game that you're playing is sort of like this. You start off with a challenge number, epsilon. This is exaggerated. It's pretty small. Epsilon can be 0.1, 0.01, 0.001, whatever you feel like. Okay. So we go like this. Here's the limit L. This is epsilon. This is epsilon. So this is L minus epsilon, L plus epsilon. In other words, the distance between the function and the limit is less than epsilon. That's what we're saying here. Okay, then can I find a corresponding band here, a corresponding delta, where the distance between x and a is less than delta, with the exception that x is not allowed to be equal. Okay. And they've shown instance here, figure 6. Okay, so you're giving me an epsilon. So I go L plus epsilon, L minus epsilon. In case you're wondering, you're normally not going to draw these pictures. Okay. So can I find a delta so that all the function values in here are within epsilon, except maybe right at x equals a? So in this case, they have. Okay, so they found a delta so that when I move either delta unit to the left or the right, i.e. the distance between x and a is less than delta, but not equal to 0. Okay? You can see that they come up with such a scheme here. So all the function values are between L plus epsilon and L minus epsilon. Okay? So, I'll show you some examples right away. Okay, so 2.4. I have 2.4, 1 to 4 all, 13, 15, and 20 all. By the way, a lot of these all, it doesn't really matter if I do an odd or an even, because they're proofs. And so they don't have the answer in the back of the book anyway. Right? I'll probably end up doing the even just out of habit, but it doesn't really matter if I do evens or odd. Okay, 1 through 4 all, I'll do the evens for you. Okay, so let's look at number 2. Page 113. Oh yeah, so okay, let me go back to the habit of trying to show you all the problems in case some of you out there don't want to get the book and you're really planning on getting it. Okay, so 1, 2, 3, 4, 5, and 6. Okay, to do the game. And we have to go to 27. So on the next page, 14. 15. Okay, the majority of this section is stuff like 15 through 27 at the end. Okay, you're proving the limit. Problem number 2. Here's a graph where we're saying the limit as x approaches 3 of f of x is equal to 2. Okay, the graph goes like this. Open circle, it jumps up to a dot over here, which we don't really care, then continues on there. So use the given graph of f to find the number delta such that if 0 is less than absolute value of x minus 2 is less than delta, then absolute value of f of x minus 2 is less than 0.5. This is the epsilon. Epsilon is 0.5. Okay, so we're saying the limit is 2. Okay, so find me a delta if epsilon is 0.5. Okay, so what they did was they go 0.5 up, 0.5 down, 1.5, 2.5, right? Okay, so can I find a corresponding band here, a delta, which is a change in the x direction? Okay, can I find a corresponding change in the x direction so that all the function values are within 0.5 units of 2, except right at x equals 3? Okay, now you can see over here, we've got 2.6 here, which is 0.4. And from 3 to 3.8, that's 0.8. So what should I use as my delta? In general, when you get a situation like that, you pick the smaller number. Okay? So delta is going to be 0.4, because if I go 0.4 this way, I'm at 2.6. I am within 0.5 units of 2. If I go 0.4 units this way, I'll be at 3.4. And yes, all of those function values are also going to be within 0.5 units of 2. Okay? But I can't pick a larger number. Like if I go 0.8, 0.8 is okay this way, but 0.8 this way is not going to be okay. I'll be further away. But you have to go the same distance to the left as the right. When you get a situation like this, you pick the smaller number. And so in a nutshell, the answer to number 2 is 0.4, because the distance from here to here is 0.4. So in other words, if I go 0.4 to the left and also to the right, then all the function values anywhere from 2.6 to 3.4 are going to be within half a unit, 0.5 of the limit 2, except right at 3. We don't know what happens at 3. Okay? So again, the answer to number 2 is 0.4. Let me show you number 4. All right, to give you the function y equals x squared. Okay, the limit as x approaches 1 of the function is 1. We agree with that, right? You can tell us they're plugging in. The limit as x approaches 1 of the function is 1. Okay, so once again, they're using a epsilon of 1/2. So I go half a unit up and down, so that gives me 0.5 and 1.5. All right, so they put question mark here, question mark here. So first I have to figure out these question marks. Okay, 0.5, 1.5, those are the y values. So how do I get the x value? The function is x squared. So x squared equals 0.5, right? So I take the square root. Likewise for 1.5. So let's go ahead and do it, and I'll go ahead and write it in the book. Okay, so square root, right? So square root of 0.5, 0.707, and square root of 1.5, and then 1.225.
What did you plug that into? I'm sorry.
All right, so they give us the y values, right?
Yep.
Y is 0.5, so the left-hand side is 0.5. 0.5 equals x squared.
Okay, thank you.
So that means I got to take the square root. And 1.5 is x squared, so I get the square root. So the square roots were 0.707 and 1.225 roughly. Okay. All right, so how far is it from here to here? Well, 0.225, right? 0.225. I can do that in my head. I don't know if I can do that in my head. So the difference between that and that function is calculate 0.293. Okay, so based on what we said for number 2, which number should I use for my delta? Smaller number. So delta is 0.225. Because if I go 0.225 this way and this way, okay, all the function values are going to be in this band. It's going to be between 0.5 and 1.5. If I chose a larger number, 0.293, that would be okay this way, but 0.293 would take me outside here, so I'll be further away than my epsilon half a unit. Okay. So in a nutshell, you take the smaller number in situations like this. Okay. All right, so that's the basic idea behind those. Now, setting you up with the beginning of a proof type of problem. 13. Find a number delta such that if absolute value of x minus 2 is less than delta, then absolute value of 4x minus 8 is less than epsilon, where epsilon is 0.1. Repeat where epsilon is 0.01, problem 13. Okay. So this is what they gave us. If you really want to know what's going on here, it is this. I'll write it here. Limit is x equals to 2 of 4x equals 8. That's really what we're trying to prove. Okay, now we agree this is true just by direct substitution, right? If I plug in 2, I get 8, although that's not really what this says. This says when I plug in a number that's very, very close to 2, right? The y value is going to be close to 8. Okay. How do I say x is close to 2? Like this, right? Absolute value of x minus 2, distance between x and 2 is less than delta. Then 4x is going to be close to 8. That means absolute value of 4x minus 8. Remember, distance between two numbers, and you don't know which is bigger or smaller, is the absolute value of the difference, less than 0.1. Okay. So this is just some simple algebra. Stop and think about it. How do I go from here to here? Well, you notice if I just simply factor out the 4, right? So start off with absolute value of 4x minus 8, less than 0.1. I can factor out the 4. The absolute value of 4 is 4, right? So this is the same thing as 4 times absolute x minus 2, less than 0.1. Divide both sides by 4. Absolute value of x minus 2 is less than 0.025. Which means let delta be 0.025. Okay, so if the epsilon you gave me was 0.1, then the delta I give you is 0.025. Okay, now in the proofs, I'll be using this arrow quite a bit. That's actually a meaningful arrow. In logic, that says implies or implication. I can spell it right. Okay. So the arrow in logic says implies. A implies B, if any of you had logic, or P implies Q. All right, so you gave me an epsilon, which is 0.1. I found a delta, 0.025. Okay, so here we go. Absolute value of x minus 2 is less than delta, implies absolute value of x minus 2 is less than 0.025, since I let delta be 0.025. Multiply both sides by 4, and absolute value of 4x minus 8 is less than 0.1. And that's the end of the proof. And you do the same kind of thing for part B. It's exactly identical. I'm really satisfying the rules of the game, so to speak, right here. Okay. Whoops. Back on page 106. Okay, you give me an epsilon. Okay, so the epsilon they gave me was 0.1. I come back with a delta. So then whenever this is true, that implies this is true. If, then, in logic. When this is true, this is true. That's what's happening over here. Okay, so you gave me a particular epsilon. So most of the other proofs, they're not going to give you an actual epsilon. We won't plug in 0.1 or 0.01. We'll just leave it as epsilon. So they gave me 0.1. By this argument here, I found a delta to be 0.025. Okay, so if absolute value of x minus 2 is less than delta, which is 0.025, multiply both sides by 4, then it is true, absolute value of 4x minus 8 is less than the given epsilon. That's what I was trying to prove. So that was 13A. You do the same thing for 13B. Okay, I'm going to stop shortly. I'll just tell you where we're headed. but I'll just give you a foretaste of what's going to happen. Okay. We're going to ask to prove something like this. Okay. So for 16, and we'll save most of this for next Tuesday. Okay, no class tomorrow, no class Monday. Most of the rest of the problems in this section are proofs. I'll just give you a little taste of it. So prove using epsilon delta. Okay, so look at 15 through 27. Prove the limit. So how do we prove the limit? Now, we're not actually finding the limit. I mean, you can just plug in and tell, right? Like for 16, when you plug in 4, you get 2 times 4 is 8 minus 5 is 3. And for 19, if you plug in 1, you're going to get 2 or whatever. Okay? But that's not the idea of the proof. So I'll show you a quick outline of the proof, and then I'll stop and give you the quiz. So just a quick overview. Limit as x approaches 4 of 2x minus 5 equals 3. Okay, this is the f of x. This is the L. This is the A. X approaches A. F of x approaches L. So how do I set it up from what I just showed you? So given an epsilon greater than 0, find delta greater than 0, such that whenever this is true, 0 less than absolute value of x minus A, x minus 4 is less than delta. That implies absolute value of f of x minus L, 2x minus 5 minus 3 is less than epsilon. So you can use this as a template. In fact, if you want to write this template on your next cheat sheet, you may. Okay? So it's always going to look like this in the start of a proof. 0 less than absolute value of x minus the A. In this case, the A is whatever this is, so 4, less than delta, implies absolute value of f of x minus L. So you take that, subtract that, 2x minus 5 minus 3, less than epsilon. Okay. And what's going to happen is you do a little bit of algebra. Okay. I'll just fly through this. Some of you might get this, but if not, just the overall big picture. Okay, so I did this, a little bit of algebra gives me that. I factor out the 2, and I divide, end up with this. In other words, I try to force the left-hand side to look like this now. From here, can I make it look like this? Yes, I made it look like this. Absolute value of x minus 4 is less than epsilon over 2. And this will be my delta. Since I got this to look like this, then I make the right-hand side be delta equals epsilon over 2. There's actually 2 parts of the proof. Part 1 is to find the delta. The part 2 is to actually prove it now. Prove that this works. And by the way, notice I don't have a specific epsilon like over here. It said 0.1. Okay, I found you 0.025. Okay. So what about if I have 0.01 or 0.0001? Do I have to find another delta? This is stronger. It's almost like a function. Okay. Because now let delta be epsilon over 2. So now I got a rule. Whatever you give me for epsilon, I just cut it in half. That'll be my delta. If you say epsilon is 0.1, I divide it by 2. The delta is 0.05. If you say epsilon is 0.000001, I divide that by 2, and I get half of that. That will work. Okay. Then you go ahead with the proof. So the proof always starts off like this: 0 less than absolute value of x minus A. Okay. You basically just retrace your steps. Multiply both sides by 2. Change delta to epsilon over 2. Multiply by 2. This gives me that. And then rewrite 2x minus 8 the way that it was supposed to be. 2x minus 5 minus 3. Okay, so that's just big picture of what's going on. Some of you may understand this. If you don't get what I said, that's okay. I'll do a lot more of this on Tuesday next week. But that's how all of these proofs are going to work in general. Okay, so you start off with the language that was in the definition. So the language you start off with is given epsilon greater than 0. You always write this stuff, given epsilon greater than 0, blah, 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 up to here, such that. Then it's always 0 less than x minus A, less than delta. The only thing you change is what the value of A is. And that implies, then here it's absolute value of the function minus the limit less than epsilon. Okay? Do some algebra to find what the delta is, and then you start the proof. Okay, but I'm going to stop there so we have enough time to do the quiz. Okay, let me check the chat. Okay, and yeah, I hear you. Okay, I'm going to try to get a mic for next time, and I'll see if that works. And that should take care of that. Okay, any other question, please, before we start the quiz? Okay, so get your cell phones out or do a screenshot. And as I said last time, this is going to be very fast. Okay, so I don't know how I can get this so that you can see the whole thing focused. Give it a try. Take a picture of this and maybe I'll break it up into two. Okay, so I'll read it for you also. Give the following or write D and E. The graph goes like so. Open circle, dot down here, goes up here, asymptote, goes down here, and continues on there. So number 1, give the limit as x approaches 0 from the left. 2, limit as x approaches 0 from the right. 3, two-sided limit, and f of 0. And 5 through 8, same thing with 2. Limit as x approaches 2 from the left, from the right, two-sided, and f of 2. So give the following, or you can write D and E, if it does not exist. Okay, that might not be able to focus. I'm going to do this. I'll raise this up just for the graph. So you want to get a picture of that graph better? Go ahead and get that, please. I'll hold it just for a few more seconds. Then I'll do the same thing for the questions themselves. Okay, so I can raise that up, but I don't think I can get the whole thing at once. So take a picture of this if you would. Okay, I do see someone wants screen sharing. I don't really, well, there's reasons why I don't want to do it. I don't think you really need to for this one. I hear you, but it's better if I don't for other reasons. Okay, so I'll show it to you again. There's that. Okay, so please take a picture in the next few seconds. And then there's that. Okay, I will now assume that you all have it. So go ahead and get started. And I'll set up the breakout rooms. Do you have to draw the graph? No, you don't have to. It might be better for your purposes to draw the graph, so then you can refer to it later. I mean, if you just look later and say, oh, the answers were whatever, what was the graph, right? So it'd probably be a good idea to draw it for your benefit as it were. Okay, so get started with it. Let me set up the breakout rooms. Yeah, you can just give me the answer. There's no work, so just give me the answer, as it were. Okay, so you're going to have a group of either 3 or 4 with persona, one of them. Of course, you don't have to put persona's name, and persona, of course, will just migrate from room to room. Okay, you should have an invitation to join your group of either 3 or 4, so please do so, and you can get started on the quiz.
Excuse me. The camera on my phone's broken. Can I just send you the answers over email, or do you need a picture of what I wrote?
Email is fine.
Okay, thank you.
Okay, thank you. Okay, Jose, can you join your group, please? Jose, you need to join your group.
I got disconnected from the.
Okay, let me try to put you in a group.
Thank you.
Okay, here you go. Jose, are you there? I need you to join your group.